FANETs-driven multimodal smart transportation system for delivery. And this we are going to give our final review. And this is our guide. And myself, Sedunarayanan, and this is Madhu Prakash. And this is the outline of what you are going to see. Manu Prakash will explain the motivation.
Thank you, Setram. As per the survey, until the December, we noticed until the December 2018, nearly 75 million cars are registered in India. It causes to me accidents and heavy traffic. So, in order to reduce these accidents and traffic, we implemented we developed a project that is VANETs and FANETs. In VANETs, it will be you can in VANETs we can communicate the vehicle to vehicle through the message. It might be a bridge breakdown or accidents in happen that road. It causes to reduce to use that road. As now, let us imagine the same technology in the air traffic also. We can use this uh, for the for you can use this for the surveillances and traffic monitoring. It will help to be in the air traffic objectives. Here we create the VANETs and FANETs by using the NS3 and including the roadside units and stimulate packet transmit the ad hoc network, showing the results for the NetSem and window flow monitor systems, and VANETs and FANETs by the varying number of nodes with the different protocols like AODV and OLSR. Introduction. Introduction of VANETs and FANETs. VANETs is a subset of MANETs. It is non-restricted mobility and high reliability. You can see the VANETs and FANETs in the picture, how they connected through the one by one. Literature survey. We did a number of literature survey. Here the few of literature surveys. So in first literature survey, they in that paper they fully explain about the VANET's architecture and routing techniques, how they implemented in their paper. And second paper of about the VANETs, they use the Sumo and NS3 simulations and algorithms and OLSR results and PDR results. How they use their how they use and how they get the results. These all things are noticed in that paper. Go to another uh, in FANETs, we notice the same routing protocols. Routing protocols it implemented for the military purposes and they for the surveillances and UV nodes and must be they in that purpose they use the protocols on and 3D mobilities. It might be used black block diagrams. In block diagrams, VANET stimulation in NS3 install the required models and creating modes and installing the Wi-Fi modules and few protocols IP address. We adding the 2D mobility and set up the stimulation. Same we can use the FANETs also, but we can changing the few protocols and adding the 3D mobility. In FANETs we use the 802.1111p and in FANETs we can use the 80.21111b. This is background studies. It will be explained by Setra.
And these are the module description the about the modules we have been discussed in the course. And like Manu Prakash said, we are using a wireless channel. So this wave module is in NS3, which is very helpful for this for creating the wireless networks and ad hoc networks. And 802.11p, which is used for particularly for VANETs. 802.11b is for MANETs, and we can also use it for the FANETs also. And 802.11 it's also used in aerial communications. And the propagation loss models are used in the VANET is two-ray ground propagation loss model, and the loss model which is used in FANET is phase propagation model. And we are using YANS Wi-Fi for wireless physical interface and mobility models. And in for planets, we are using the common random wave point mobility model. It has two variants, which is random walk model, which changes velocity over the simulation time, and random direction model, which changes its direction over the simulation time. And when we come for the FANETs, the Gauss Markov mobility model, which is a 3D mobility model, with in with the use of this, we can clearly see the simulation of the uh, nodes which is moving in the 3 dimension in the net and in window while running it. And Gauss Markov model is popular due to its realism, versatility, and consistency. And routing protocols are these routing protocols are the algorithms or which which helps the routers to interact with one another and share data via the via the chosen rules, which are via the chosen routes between the nodes and the computer networks. And some of the ad hoc routing protocols are divided into proactive, reactive, and hybrid. In proactive, that is DSDV and OLSR comes under proactive. AODV, DSR, ABR comes under reactive, and ZRP and TORA comes under hybrid. And in our simulation, we used both AODV and OLSR. Which one is AODV is on-demand protocol, and OLSR is a proactive link state protocol, and it works on the principle by keeping an routing table. And routing table consists of three main things, that is next hop node, sequence number, and hop count. With these things, it will create the which creates how much number of hops and that are needed to reach from source to destination. And we see for OLSR, it will it will use the shortest hopping forward methods, hopping paths, and the particular node will compute the next hop destination for next other nodes in the network. Now we will go for the simulation, the demo part. And we are using our Ubuntu Oracle VirtualBox in the Ubuntu, and downloaded the Ubuntu environment for NS3 software. And this VANET routing is a file, is a C++ file that is used to code. And the coding is we have discussed in this block diagram section explained by Manu Prakash. Like same wise, the codes have been written, and with the parent classes and child classes uh, for the easy use. And we are determining how much and what protocol we are going to use, what propagation loss model we are going to use, at the rate at which the wireless physical mode transfers their information. And we are setting this 802.11 mode. And if we go through this, then we can see this node speed also. We are setting up to 20 meter per second, and we can see here, and we are scenario 1 is for like simulation scenario, artificial simulation scenario, in which we are creating only 20 nodes for this simulation. And this scenario 2 is for the real time simulation. We can see that in the future plans, that we can do it with integration or not. And by simulating this VANET, actually it takes a long time. So I have pre-run the program and kept. This is and we have installed two other extra modules, like animation module and flow monitor module. And the flow monitor module takes each flow, like from source to destination, receive packets, sends packets, and the ratios and all. And it will averages it and tells about this overall total results of the simulation. From this, we can take the data and plot the graphs for the analysis. And for the same for the and if we run this FANET routing compare also, we can see the same type of like a similar type of results coming through it. I will show you. And meanwhile, the FANET routing compare runs. We will visit the results for the VANET simulations. And this is the NetAnim software, and uh, we are going to click on what file name we have saved. Like this is the file now we have ran. See, you can see the node numbers that are displayed here. I will zoom it a little bit. If we play it means you can see the packet transmission having between this happening between these models. And if we zoom further clear, we can see this node movements that is also happening here. So, this is the NetAnim output simulation. For the flow one, you have already seen in this terminal window. I will stop this and go to the FANET. And now the FANET simulation has run, and you can see this total number of values that has been transmitted, received, the PDR ratio, average throughput ratio, delays, and all. This is for the total simulation. And for this one, we are going to see the NetAnim simulation. Oh, sorry. And this is the file. You can see the file, and little bit zoom it. You can see the node numbers. When we play it, you can see the transmission that is happening between the nodes, and after a certain time, the mobility when the mobility happens, you can see the nodes moving out like this. This is the aftermath of the mobility, like, and the transmission is still going on. This is the simulation output for this VANETs and FANETs. And now we come to the results. And this is the uh, output results we have took from the varying the number of nodes for the different protocols, the PDR value, average throughput value, and the end-to-end delay. And this is the output graphs, and this is the results of the simulation. We can see that OLSR performs well in terms of PDR and delay. It has low delay than AODV and has high PDR ratio. And in terms of throughput, AODV has more values than OLSR. And same for the simulation. This is the table we took from the results. This and in fun for OLSR, OLSR has only less delay compared to AODV in terms for VANET, and for the average throughput and PDR, AODV performs efficient than uh, OLS. AODV performs efficient than OLSR in the FANETs. So we conclude here we conclude by analyzing the performance of the AODV and OLSR protocols in terms of average throughput, delay, and PDR by varying the number of nodes. According to our results, just now I said that AODV is better for FANETs, and OLSR is better for FANETs. And our future work will be integrating the VANETs and FANETs using 5G LTE as an evolved node-based station for a broadcast network in the network simulation platform. These are the references, and thank you.